we're looking at this. This is a vector problem. Now, in your formula booklet, you have something that's called the dot product. Right there, where is it? No, you don't want the vector product. This thing right here, the scalar product. And the scalar product tells you that the cosine of theta is equal to, this is the dot product of the two, A dot B, over the absolute value, over this times this, right? Where these things are the size of the vector, the magnitude of the vector, and the dot product, this means that you're going to do A1 times B1 plus A2 times B2 plus A3 times B3. And the magnitude is the square root of A1 squared plus A2 squared. Does this ring a bell?
Mm-hmm.
Yeah?
Yeah.
Let me, up. All right, and B is going to be the same thing. So, B1 squared plus B squared plus B3. Keep writing 3 right there. Squared. So far, so good?
Yeah.
At this point, I just plug in my values. A1 is 2, B1 is minus 3, plus K, times K plus 2, plus minus 1, times K, plus minus 1, times K, over 2 squared plus K squared plus 1 squared. This will be 3 plus K squared. Sorry, 2 squared is 4. 2 squared is 4, right? 5 plus K squared over minus 3. Well, here I'm not going to do. This is going to be 9 plus K plus 2 squared plus K squared. Now at this point here, I'm going to stop because I was doing this for teaching purposes, because really they're perpendicular. If they're perpendicular, what do we know about the cosine? What's the cosine of 90 degrees?
0.
That's right. So therefore, this is equal to 0. And if this is equal to 0, it's only possible if the numerator is equal to 0. So what we have here is that minus 6 plus K squared plus 2K minus K is equal to 0. So that gives us K squared plus K minus 6 equals 0. We can factorize this. K plus 3, K minus 2 is equal to 0. Therefore, K is equal to minus 3, or K is equal to 2. These are now the possible values of K.